Okay, class, good morning. To start, I would like to recall on the previous lessons that we have tackled last week, and that is about balancing equation. Okay, you have learned about how to balance equations and identify the different kinds of chemical reactions and what are the evidences that would prove that there is a chemical reactions. But again, there is an exemption on that regarding the quantitative and qualitative analysis that a chemical reaction should be subjected because there are certain chemical reactions without evidences. Also, it is very important to take note that only coefficients should be changed or altered in balancing chemical reactions. I also taught you how to identify the different types of chemical reactions. So in connection to that, uh, let's continue the lesson with mole and mass relationships. Okay. To begin the mass-mole relationship, let us begin our study with the definition of formula weight. Okay, and molecular weight. Actually, these two are an overlapping definition. Okay, so what is formula weight? Formula weight of any substance is the sum of the atomic weight in atomic mass unit, AMU, of all the atoms in the compound's formula. Okay, so when you use formula weight, this is applicable for both ionic and molecular compounds. Okay. So how it is different from molecular weight? When you say molecular weight, this is the term used for covalent compounds. Though such terms were just overlapping to be used. Okay, so sometimes you can use molecular weight or formula weight. But to avoid confusion, let's stick with the word formula weight. Okay. Now, so you had the periodic table of the elements to find the atomic weights. Okay. So also the word atomic weight, also sometimes called atomic mass. So if you would look at the atomic weight or atomic mass of hydrogen, oxygen, okay, in the periodic table, hydrogen has an atomic weight of 1 and oxygen has an atomic weight of 16. So for us to compute the molecular weight, we have to consider the subscript that you see in the compound water or H2O. So 2 is multiplied by 1, and for oxygen, 1 is multiplied to 16. So meaning the atomic mass unit of water is 18 grams per mole. So you take note of this because these were the units used for the conversion of mole and mass relationship. Okay. Now, what is a mole and how do we use it to calculate mass relationship? Okay. So previously, we have encountered the word molecules, uh, grams. Okay, it was defined to you that when you say grams, this is the amount of matter that an object contains. Okay, so when you talk about atoms and molecule, both of them were so tiny. Okay, I also informed you before that when you say molecules, this is most precisely applicable for binary compounds. Okay, so they were so small in quantity, okay, but they also had their huge formula units. So mostly we used exponential notation or scientific notation in expressing large numbers, particularly on decimal places. So the formula unit may be atoms, molecules, or ions. So for now, it is really important for you to take note the differences between an atom, a molecule, and an ion. Okay, so to overcome this problem, chemists long ago defined a unit called the mole, M-O-L-E or M-O-L. Okay, so when you say mole, this is the amount of substance that contains as many atoms, molecule, as ions as there are, okay? Exactly for 12 gram of carbon. So you know carbon is an element found in the periodic table. So, pag nag-pertain lang tayo dun sa mismong mass nung element na yon, that's 12 grams already. Okay, so this is the atomic mass. And to define atomic mass again, what is atomic mass? It is the combination of the mass of proton and neutron, or the number of proton and neutron inside the nucleus of an atom. So even if we're dealing with a mole of iron atoms, a mole of methane molecule, or a mole of sodium ions, okay? So may isa lang ang number niya, may isang formula unit siya, okay? So ibig sabihin, kung sabihin natin what is the mole of that element in the periodic table, so 1 mole of carbon is equals to 12 grams of carbon. Okay. So we also use mole in dealing up with compounds. So pag compounds na, so dito papasok yung formula weight na tinatawag natin. And the unit is atomic mass unit. Okay? Now, you take examples of bags of eggs by the dozen and pencil by the gross. Okay? You see, when you are buying items by the dozen, you always say it's dozen. So it's already identified by the seller that you're going to buy that by the dozen. Also, in terms of pencil, okay, ginagamit yung salitang gross, no? Okay, dun sa mga motorcycles, yung mga nasa mga tire nila, those uh, steel that are found in the motorcycle, yung umiikot na kasama nung tire, okay, ang tawag doon ay rayos, and it is bought by gross. Okay, so matic, pag sinasabing gross, it's made up of 144 units. So, dozen was used. Okay, so if you're not going to buy this by pack, okay, you use the word pieces or piece. Okay, so parang ganun yung mole, no? So it's a useful scale of factors for atoms and molecules. So later on, we will see the number of units is much larger for a mole than for a dozen of a gross. Okay, so para sa mga formula units in a mole, we call that Avogadro's number. It was proposed by an Italian physicist, Amadeo Avogadro. Okay, siya yung unang nag-propose ng concept ng mole. But actually, he was not able to determine this experimentally. Okay. Its value is known to 9 significant figures. So, when you talk about Avogadro's number, tandaan natin that this is constant. Okay? So, this is constant. 6.022 or 6.02214,199 times 10 to the 23. Okay? So, this is exponential or scientific notation. Okay? These are the multiplying factors. This is the power of 10. And the exponent can either be negative or positive. So, for most calculations, nira-round off yung number sa tatlo. So, mostly, pag multiplying factor, lagi siyang tatlo. Although, makakakita kayo ng isa o dalawa. Pero, if you're dealing up with significant numbers to be included, lagi dapat ay tatlo. The first number, dot, then the two numbers that follows. Okay. So, a mole of hydrogen atom is 6.02 times 10 to the 23 hydrogen atoms. Tulad nung mole ng sucrose, which is the table sugar, no? So, 6.02 times 10 to the 23 are the sugar molecules. Pareho din kung ano yung meron yung apple or apples. Pareho din kung ilan yung nasa sodium ion. Okay, so ibig sabihin, the Avogadro's number is constant. Okay, so as just we call 12 of anything a dozen, 20 a score, and 144 a gross, we call this 6.02 times 10 to the 23 of anything that is a mole. Okay? So, yung molar mass ng substance, the mass of 1 mole of any substance is the formula weight of a substance expressed in grams. Halimbawa, yung formula weight ng glucose ay C6H12O6. So, saan ko nakuha tong 180 na to? Diba? 16 times the atomic mass of carbon, 12 times the atomic mass of hydrogen, and 6 times the atomic mass of oxygen. Then you add all of them, and the sum is 180 atomic mass unit. Therefore, the 180 grams of glucose is equal to 1 mole of glucose. Okay, same thing with the formula weight of urea. So ganito rin sa urea. Same procedure lang din. And therefore, that 60 grams atomic mass unit is equals to 1 mole of urea. Okay. So sa mga atoms na 1 mole is the atomic weight expressed in grams, like just for carbon, which is an element, okay? And 1 mole of carbon is okay, 12 grams. 32.1 gram of sulfur is also 1 mole of sulfur atoms and so on. So this is applicable to all elements found in the periodic table. As you see, the important point here is that to talk about a mass of a mole, okay, and to identify its relationship to each other, okay. Now, based here, you could see a diagram that shows the relationship. So, kung magko-convert ka ng grams to mole or grams of A to moles of A, okay, you will be using grams per mole, okay. But if you're going to convert moles of A to grams of A, we'll be using moles per gram, okay. So, this is an example. Suppose you wanted to know the number of moles of water in graduated cylinder. So, pag naglagay ka naman ng tubig sa graduated cylinder, irregardless of hindi yan nakokontrol, pwede mong dagdagan. So, you have to measure its mass. Okay, so how to measure the mass of water in a graduated cylinder? Pag actual laboratory na, dapat ay i-measure mo muna yung mass ng graduated cylinder, then you add water and take its mass again and then subtract. Kasi para mawala yung mass ng graduated cylinder at ang makuha nyo lang ay yung mass ng water. So, sabi dito, meron kang 36 grams ng water. Okay? So, gusto mong malaman kung ano yung molar mass ng water. Okay, so alam mo na na ang water ay may 18 atomic mass unit or 18 grams. Okay? So, kailangan mo kasi yung grams na unit, okay? So, if 18 grams of water, then 36 grams must be 2 moles of water. How do I find or how do I solve these 2 moles, okay? So, bibigay mo yung given, okay? And then, you have to cancel. You have to cancel this, okay? So, para makuha mo yung mole, okay, so 36 divided by 18 is equals to 2. Okay. Therefore, for 36 grams of water, there is 2 mole of water. Okay. Molar mass can also be used to convert from moles to gram. Okay, suppose you have a beaker that contains 0.753 mole of sodium chloride and you are asked to calculate the number of grams of sodium chloride in the beaker. Okay, so the conversion factor use the fact that the molar mass of sodium chloride is 58.5 grams per mole. So ito yung given mo kanina, no? Gusto mo itong i-convert sa grams. Okay, so kailangan ilagay mo siya rito. Then automatic, you have to use the unit mole of sodium chloride at the bottom of this. And then 58.5 is what you have computed as the formula weight of sodium chloride. So you cancel this and then you multiply 0.753 to 58.5 grams. Then you got 44.1 gram of sodium chloride. Meaning, for 0.753 mole of sodium chloride, that is equivalent to 44.1 grams of sodium chloride. Okay, so ito yung pinaka uh, uh, summary natin, no? Okay, so kung gusto mong mag-convert ng mass of substance papuntang moles of substance, okay, you will use the unit mole to gram, okay? Then if you wanted to convert mole of substance going to mass of substance, you will use the gram per mole for you to be able to cancel, okay? So it's very important that you were able to cancel. Okay, these are the examples. Okay, so you see here that if you're going to convert 18 grams of water to moles, okay, naibigay ko na itong example kanina. Kaya lang, yung grams kanina ay 36. If you would look back at the previous slides, ito naman ay 18. So 18 divided by 18, ibig sabihin, sa bawat 18 grams ng water, mayroon kang 1 mole of water. So let's have example number 2. If you have 34.5 grams of sodium chloride, okay, how many moles of sodium chloride do you have? Okay, so you will be canceling out gram of sodium chloride. Then you will divide this by 58.4. Then you got 0.591 moles. Okay. So for the next example, okay, so we have here 27.5 of sodium chloride. Okay. Uh, So, how many moles is this? Okay, so gusto mo namang malaman yung mole ng sodium fluoride. Given na 27.5 grams. So, 27.5 grams of sodium fluoride. Okay, you have to divide this by 42. Okay, yung cancellation, wag niyong kakalimutan, no? Then, the unit now is in mole. Okay, so mahalaga lang na malaman nyo na ang formula weight ay kailangan nyo makompute because that is constant. Okay? Now, you wish to weigh 3.41 mole of ethanol, C2860. Okay? Gusto mo namang malaman kung ilang grams to. So, we have the same formula here. Okay? So, nakita nyo na. Then, you have 157 grams of C2860. Okay. And for the last example, ito na yun, no? What if, okay, what if the required is the mole of that ion in the compound. Okay, so this is, I think, the most complicated problem regarding this lesson. Okay, ito yung medyo, pag ginawa nating mas komplikado yung isosolve nyo. Okay, how many moles of nitrogen and oxygen atoms are there in 21.4 mole of the explosive trinitrotoluene or TNT, C7H5 N3O6. So, kanina, okay, inaalam nyo lang kung ilan yung mole ng substance dun sa compound, di ba? Okay. Pero dito, aalamin nyo na kung ilan yung mole mismo nung ion dun sa substance. Okay. So, gagamitin nyo yung 21.4 mole ulit. Okay. Tapos, saan ko nakuha tong 3 mole? Dun sa subscript ng nitrogen. Okay, this is the subscript of nitrogen. So, I put 3 mole here. So, nakadepende yun sa subscript ng ion dun sa loob ng compound. Okay, you remember that. So, 21.4 multiplied by 3. So, therefore, in trinitrotoluene, there are 64.2 mole of nitrogen atoms. Okay. So, this one naman, gusto mong malaman yung oxygen atoms naman, no? Okay, so, gagamitin mo ulit yung given mole ng TNT, but this time, you will be using 6 because 6 now is the subscript of oxygen in the compound. Okay, so I think I suggest that you have to practice on how to look for the mole of carbon and hydrogen. Okay, I hope you understand, and if there were other questions, please don't hesitate to uh, give your class representative the uh, question that you'd like to ask. Okay, thank you.